Page 258, example number 3. So here we have two quadratic equations, and we're going to use our four-step method to solve for them. So step number 1, is the equation equal to 0? Yes, it is. Everything is expanded. So that means we should be able to factorize, which is our second step. So in this case, how are we going to factorize? Well, there's no GCF between these terms. So I'm going to have to use my decomposition or chart. So in order to use my decomposition, I'll say, okay, 3x and x. And then for 10, let's put a 5, 2 and 5 this way. This gives you 15. And that gives you a 2. That actually will work out fine, I think, as long as 15 is negative and 2 is positive. So that means this is negative, this is positive, and it works out to be negative 10. So factorization is done. So these are my two factors. And here I have two factors equaling to 0. That means now I can set up using my zero product law. That means both of them could have a possibility of becoming a 0. And the last step is to solve for x. You could do this in one step if you're comfortable just knowing that this will always go to the other side and get divided by this number. Or you can do it in these multiple steps. Either way, it's fine. And the last one will become positive 5. So that's one answer. Those are the two answers that we have here. Now, other times what would happen is your equation may not be equal to 0, and sometimes there are even like brackets on each side. So you want to make sure you expand it completely and make sure it's all on one side. So this one you would move the 25 to this side. So even if this was sometimes written like, an example could be written like this. In that case, you would expand it out to make it this form, bring the 25 that like we're bringing it on this side. You want it to be in expanded form so we can use our factorization skills completely. Once it's on one side, then you can start saying, okay, what are my tools? I can do factorization. So I'm going to take a 5 out because I can do a GCF out of all three of them. Then my factoring becomes much easier. I can do it by inspection or by chart. And then we have three factors, but the first one doesn't have any x in there. So there's nothing to solve, no x to solve for. So we only will focus on these two. You can't say 5 equals to 2. That's just wrong thing to say because 5 is 5. It's not equal to 0. So only focus on the factors which have an x to solve for. So x would be negative 5 and x will be negative 1. So those are my two answers for this. Okay. Now there's also an example number. Let's take a look at example number 4 here, which is a word problem. And in this word problem, it says the area of a rectangular sheet of paper is 300 meters. So we know area is 300 centimeters squared, sorry. And this is the part that we need to pay attention. The length is, so that's how we set it up. Length is 5 more than, it's 5 more than something, I don't know what, the width. Okay, so it's 5 more than the width. So if I knew my width, I would know that my length is 5 more than that. So the unknown variable that I should find out is my width, which should be my x, which means my length would be x plus 5. 5 more than something, 5 more than the x. So this is my length, this is my width, and area is length times width. So 300 is equal to x plus 5 times x. So remember what I said, expand out everything. So we're going to expand out this. So it becomes x squared plus 5x. Bring everything to one side. I'm just going to take the 300 to the other side. So as long as my equation is equal to 0, that's all we need. And then we're going to factorize this. And the factors that break this down are going to be, it's going to be x plus 20 and x minus 15, which gives me my two solutions. X can be negative 20 or X can be positive 15. So if I use the zero product law, those are my two answers. So mathematically, these are two correct answers, but because this is an application question, right, we're applying this answer to a real situation, then we need to think about if both these answers make sense or not. So can my width be negative 20? Well, no. Width can't be negative numbers. So because of that, you would have to reject this answer. Okay? Put that X back in the scenarios. Okay? Will it make sense for both of these scenarios? If it doesn't make sense for either one of them, you can't accept it. So, does X make sense to be positive 15? Let's see. Can my width be X? Yes. Can my length be X plus 5? Does that number also make sense? Yes. So, okay, good. So we know that the length and width are 15 and 20 centimeters. Go back and read the question as to what they're asking. Did they ask for dimensions or did they ask for anything else? So they said form a polynomial equation to solve it. We did. And they said solve it. We did solve it. And then the final thing they're asking us to do is to find the perimeter. So always go back and read the question. So the perimeter is going to be 2 lengths plus 2 widths. So altogether, my perimeter will come out to be 70 centimeters. So this question is really good in making us check everything, not only setting up the equation, but making sure that our possible answers work, if we can accept either or neither one of them. Sometimes none of the answers work. And then finally making sure we answer what they're looking for, not just what we solved. So good example.